We have a radical equation here, but unlike ones we did in previous videos, this one's got multiple x's in it. One's underneath the radical and one is not. So in these situations, what we want to do first is get this radical isolated if it's not already isolated. In this particular example, this whole right side is all underneath the square root symbol, so that radical's isolated, and now I'm just going to get rid of that radical. The way to get rid of a radical is to use the equally powerful exponent. So this is a square root. We all know the implied value of this root is 2. So I'll take both sides to the second power. And the square root and the square will cancel each other out, giving the right side of 6x plus 7. And the left side becomes x squared. Now this is what's left to solve, and we can see this is a quadratic because we have an x squared term, we have an x term, we have a 7. Most of these, if not all of these, should be factorable, so you should try to factor them. If you are unable to factor them, of course, you always have the quadratic equation to help you out. And like all these types of problems that involve radicals, once you solve it, you need to check your answers, because it could be that one or both of the answers you found isn't actually a solution, even though all your math is correct. So let's go through the business of trying to solve this. It is a quadratic, so you know to get 1 to equal to 0, it's better to keep the squared term positive. So I will subtract a 6x and 7 from both sides to get the equivalent equation x squared minus 6x minus 7 equals 0. Then I'm going to try to factor this thing out. So I want two things that multiply to make x squared. That could be x and x. Two things that multiply to make negative 7, and add to make negative 6. So that'll be negative 7 and positive 1. Now that I have the quadratic factored and equal to 0, I can set each factor equal to 0. X minus 7 is going to equal 0 if x equals 7. So that's one possible solution. X plus 1 equals 0 if subtract 1, if x equals negative 1 is the other possible solution, but I got to check these both. So the original equation was x equals the square root of 6x plus 7. Let's check this one first. If x is 7, then this becomes 7 equals the square root of 6 times 7 plus 7. There's obviously no work to do on the left side, but on the right side I can look underneath this radical, take 6 times 7, which is 42, and add another 7 to get 49. And then the square root of 49 is 7, so I get the statement 7 equals 7. That's true. 7 does equal 7. So that's one of my answers. Now I'll check to see if negative 1 works. If x equals negative 1, then this x is negative 1 equals the square root of 6 times negative 1 plus 7. There's obviously no work to do on this side, but if I start to simplify this, 6 times negative 1 is negative 6, plus another 7 is positive 1. The square root of 1 is just 1. The left side is negative 1, so I get the statement negative 1 equals 1. That's not true. So this is actually not a solution. Even though all my math to find it was correct, it doesn't work. So the final answer to this problem is x equals 7. Good luck.